Hello. Hello world, watching ESA's the world's first, live stream coming to you from Mars. We're expecting the first image to arrive to Earth, and then to YouTube, and then to your eyes in about 5 minutes. We know you've been waiting for a while. We're very happy with how many people have joined. I'm Rosa. To introduce myself, I'll be moderating today, and you have live audio commentary to let you know about what's happening on screen in front of you. So this is, to everyone who's just joining now, welcome to Mars Live from ESA, the European Space Agency. Again, we're about 5 minutes away from the first live image arriving at Earth. And these images are being sent down by Mars Express, our spacecraft in orbit around the red planet. And actually, Mars Express turns 20 today. So this is why we're doing this live. It's to celebrate Mars Express's 20th birthday, the mission that was only planned to last 2 years. As a little disclaimer, the images are coming from the visual monitoring camera, also known as the VMC. It's a low-quality camera, originally developed in the late 90s purely for engineering purposes. So for that reason, don't expect too much in terms of the quality. It's got the nickname Mars Webcam for a reason. So I'll introduce you to the two experts who are in the room with me today, and they'll be answering any questions you have if you put them in the chat. I have Simon Wood with me. Maybe, Simon, you could introduce yourself.
Hi, I'm Simon. I'm a spacecraft operations engineer on the Mars Express flight control team. So I'm one of the people whose day job it is to actually operate the spacecraft and ensure it's working correctly and taking all of the great science observations that it's been doing over the years. I'm also particularly responsible for the VMC camera as well. So we've been sort of heavily involved in that over the years. As Rosa was saying, I mean, it has been nicknamed the Mars Webcam for a reason. It's very much the type of camera that you would have walked into your local, I guess, PC World if you were in the UK, or Saturn if you were in Germany. I don't know, maybe Jorge could tell me what the equivalent is in Spain, but in the early 2000s, and because it was there for one reason and one reason only. It was there to take images of the Beagle 2 lander that Mars Express carried to Mars, specifically such that we could see that it was deployed correctly. And in principle, once those images were taken, it was going to be turned off, and there was no plan to turn it back on again. The flight control team, a few years later, decided to have an attempt at recommissioning it, or at least seeing if it still worked. And I think to everyone's surprise, it did. And so for quite a few years now, we've been using it to take shots of the red planet from typically from high altitude, and placing them on social media and on Twitter.
And I just want to say we're 2 minutes away now from the first picture, and in case you're wondering, the graphic that you're seeing moving across the screen many times is what we expect to see over the full hour. So as each picture comes in, Mars will move from the top right of the screen to the bottom left of the screen. So the first image you will see will only have a tiny little bit of Mars in the top right-hand corner, and because it's the first image, it will be extremely overexposed. So the quality will get better after the second picture. And I'll pass over to Jorge, who is a true expert when it comes to the Mars webcam, and he could introduce himself and a little bit more about what's happening, and expect the first image in about a minute.
Hi, good evening. My name is Jorge Hernández Bernal. I am one of the people in the science team of VMC. It's in the last 5 years, more or less, we have been working to make from VMC not just an engineering instrument, but we have been recommissioning it to be a monitoring camera in the day-to-day, and also one in the day-to-day, and also one of the persons who work on the data processing of the camera to make it available to the world. And in the last, we are very close to have the first image. Actually, we have been working a lot in the last few months to make a specific software, because we usually we don't retrieve science data in real time. So we needed really to change our operational software to make sure that we are able to retrieve the data in real time as it reaches to the ground antennas.
Oh, it looks like we might have something. And just to remind you, for anyone who's just joined now, this is the first ever live stream from Mars, and it's coming from the Mars Express spacecraft. That is an ESA mission, 20 years old today, so wish Mars Express a happy birthday. And it, about 16 minutes ago, sent its first image down to Earth, and the teams here have been working very hard to make it possible that you can see that as soon as humanly possible. It's coming, everyone's quite excited. As we said, the first image will be quite overexposed, and Simon and Jorge can explain a bit why that is. And the images after that should be a bit more detailed. As we've said before, this is, here it is. This is the first image from Mars, and it's the most live you'll ever get, unless you travel to Mars, to the red planet itself. This is Mars 16 minutes ago, and Simon, maybe you can explain why we can't see what's happening right this very moment.
Well, it's actually very simple. Mars is a very long way away. As we can see on the actual stream at the moment, over 300 million kilometers. The images are traveling effectively from Mars Express to the ground station in Cebreros in Spain right now. And even though they're traveling at the speed of light, that distance is so huge. It takes 16 minutes and 44 seconds right now for those images to travel from the spacecraft back to Earth. So what you're effectively seeing right now is essentially, if you were currently sitting on board Mars Express and effectively sort of looking to your left, then this is what you would be seeing. We typically don't normally get images in this way. The way in which Mars Express captures most of its science is what we would call store and forward. So basically, it will look at a part of the red planet. It will take pictures or use its spectrometers or its subsurface radar to collect the data. That data is then stored on board the spacecraft, and at the next opportunity that we have to talk to the Earth, because on Mars Express, the actual antenna system is attached to the spacecraft. It doesn't actually move. So we have to slew the spacecraft to look at the red planet and then slew it back to point the antenna at the Earth. And so the next opportunity that we have, we transmit the data back. So, the scientists could typically be waiting, a couple of days potentially for some of their observations. Today we have a very unique sort of opportunity where we've got an ability to have a very specific pointing. So the spacecraft is not in its normal Earth pointing mode right now. It's sort of slightly rotated towards the planet, because that then allows us to enable VMC to see Mars whilst we can keep the antenna pointed at the Earth. And in fact, actually, the reason the stream is actually only about an hour long is because we can only really maintain this pointing for about an hour because of the way in which we have to orientate the solar arrays, and so it will start to put a load on the spacecraft's batteries if we were to stay like this for too long. This is certainly the first time that we've ever actually been getting, real science data back in real time. It's quite a rare occurrence for deep space missions.
And for anyone who's just joined, a quick reminder that this is Mars Live, and this is for Mars Express's 20th birthday from ESA, the European Space Agency, and we're looking at, I think this is still the first image, or possibly we're getting the second image in.
No, this is the number 5.
Ah, we've had 5 images. Okay. Oh, you can actually see it move a little bit. That is cool. It will get more, you'll see more of Mars soon. Maybe, Jorge, you can also say why we're only seeing a little bit of Mars at the moment.
Yeah, actually, as Simon was commenting, right now Mars Express is a very specific pointing, because the antenna is pointing to the Earth and BMC is pointing to Mars. And because of that, we are going to see how Mars is moving from the top right corner to the bottom left corner. And now it's still in the corner. We can see that in the top part of the image, it's the night. It's much darker because it's the night there. Actually, in the bottom, in the right side of the image, we have created this three-dimensional graph showing the position of Mars Express and the planet. And we can see in this graph the night, the day, and also we can see a curve on the planet that represents the part of the planet that we are seeing. We are seeing the southern hemisphere of the planet. And actually, it's very funny because we are seeing a cloud next to Garcia Mons right now. It's kind of hard to see that in the left side of the image, there is kind of a white thing that corresponds to a cloud in Garcia Mons. This is not the famous Garcia Mons elongated cloud, which, as many people know, those who follow BMC, that's a cloud that we found some years ago that expands up to almost 2,000 kilometers. In this case, this is not that very special cloud, but this is a different cloud. This is an orographic cloud in Garcia Mons. We are right now in Mars. We are approaching we are in the aphelion season, which is more or less the cold season. We are also approaching the northern summer solstice. So actually, in Mars is right now kind of a similar time of as in the year. And in Mars, because we are in the aphelion, we are in the colder season, and this is not the dusty season, not that season in which we have the dust storms, but this is the season in which we usually see a lot of clouds, mostly in tropical latitudes. Well, we are lucky because we don't always see so clearly a cloud with BMC, and in this case, Garcia Mons is very close to the border of the planet, and there is an orographic cloud there. There are other features in the image. Actually, as I told, this image is showing basically in southern hemisphere of the planet, and we don't see the South Polar Cap because the South Polar Cap is now covered by the night. But around the area, usually in this season, we can find a lot of hazes. Just they are very hazy and they are not so clear. But I think that I can see that it's a bit cloudy in the southern hemisphere.
So I see we're getting a few questions in at the moment. So one of them was actually how much time does it take Max to actually make a full orbit of the planet? And it's actually just over 7 hours. So we typically do about just over 3 orbits a day. And actually, as Jorge was mentioning, you can see part of the planet is actually in darkness because it's nighttime on the back side of the planet. And actually, what you will notice is that as the planet is moving effectively from the right to the left of the screen, so we're actually heading into the darkness, and that's actually a particular effect that happens throughout the Martian year. So Mars Express's orbit periodically takes it in a position where the planet is between the spacecraft and the sun. So that's actually where we're heading right now. So in a few hours' time, the spacecraft will be behind the planet with the reflected sun and effectively in darkness. And so at that point, its solar arrays are no longer generating any power, and it's completely reliant on its batteries to stay alive. And so this is a particular, the eclipse seasons that we have an impact on the operations of the spacecraft. And on the science as well, because obviously, whilst we're eclipsed by Mars, we're completely reliant on the batteries for power. So we have to dial down the amount of power that we're consuming so that we don't hit the batteries too hard. So we have to turn off some of the science instruments, or we can't run them for as long, or we have to take measures to to keep the spacecraft warm, because obviously not only once it goes behind Mars and it's no longer in sunlight, not only do we lose power, the spacecraft is also getting very cold. So we take steps to try to reduce the overall power consumption by doing things such as, once this stream finishes, a lot of the heaters on board Mars Express will then switch on and go on to full power to try to basically warm the spacecraft up as much as they can, such that when we approach the eclipse entry point and then we lose power from the arrays, those heaters will then go off. The spacecraft will cool down, but it will be cooling down from a much higher temperature, so that the heaters don't need to come on whilst we're in eclipse and we don't have power from the arrays. And so come back out the other side, the spacecraft will be cold, the heaters will come back on, it will warm up, but we won't be using the basically by running them, by keeping them colder and not discharging them more than about 40%, they've actually survived much, much longer than we ever thought they would. And in fact, actually, even some of the battery experts who've analysed our telemetry are quite amazed at actually how well they've held up. So I think the takeaway from that is that if you really want your mobile phone battery to last a long time, then don't discharge it more than 40% and keep it in the fridge at all times.
You heard it here first. We're actually about to be joined by one of the Mars scientists that works at ESA, so we can tell you a bit more about what's happening at Mars. Has there ever been life on Mars? Could there ever be life on Mars or water? But for anyone who's just joining, again, this is the first ever live stream coming direct from Mars. It's taking about 16 minutes for light signals to get to us. And we're getting this footage from ESA's Mars Express mission, whose birthday is today. And it's coming from the visual monitoring camera on board Mars Express. And actually, we have Colin here, who perhaps can introduce himself and maybe could talk about some of the other cameras on board Mars Express, as well as this one and its views.
It'll be in 1 hour 45 from now. So we're preparing a toast for that occasion. It's special for me because I did my PhD. I built a bit of equipment which went up on the Mars Express rockets. It was part of the weather station on the Beagle 2 lander, which went up with Mars Express. So that launched on the 2nd of June. It then arrived at Mars in December, on Christmas Day, 25th of December, 2003. Unfortunately, it was not successful in landing and then communicating back to the Earth. But we all knew it was a high-risk mission, but it was certainly a very emotional time for us all watching and waiting to see whether that survived. But that was Beagle 2, the lander, and of course Mars Express, the orbiter, has had a tremendously successful 2 decades of exploration of Mars. But I don't want to just talk about myself. What are all the questions which people have been sending in about this stream?
Well, some people are asking about life on Mars, water on Mars, and we had a specific question about one of the clouds on Mars. What's it made of and what is it? And I think this is in relation to what Jorge was telling us earlier about the huge elongated cloud that looked a bit like a volcano was erupting, but I think it wasn't.
So I think really the experts about the clouds, especially around the volcanoes, are the science team behind this VMC, this camera, of which Jorge is probably really the leading expert. So I'll hand back to him in a minute. But in general, if you want to ask about water on Mars, really the Mars Express spacecraft was put together to investigate water in all its forms. So from subsurface water and ices, looking for that. And Mars Express, one of its first results was demonstrating that there is indeed water ice in the polar caps of Mars. And not only can it see the water ice in the polar caps of Mars, but it detected strong radar echoes from the subsurface. And then strong radar echoes from the base of the polar cap, which suggests there might be liquid water underneath those polar caps. Now, this is still controversial. The interpretation is not simple. It might be liquid water mixed with ice, a bit like a slush, but that's certainly very exciting. But so Mars Express has been investigating water there. It's been investigating the history of water on the surface. So these valleys carved by rushing water torrents, rocks which must have formed in the presence of water, so hydrated minerals and clays. And then up in the atmosphere, the atmospheric water cycles, the clouds as demonstrated, and then even the escape of water to space. So the questions are, what are light spots and white spots? And really for this, I have to turn back to Jorge, who is the expert in these clouds.
A couple of minutes ago, as Mars is moving our field of view, a new clear cloud has appeared. This is a cloud that it actually looks like a bright spot in the right field of the image right now. And actually, this is a high altitude cloud. Probably this cloud is something around 50 or 60 kilometers over the surface, and it's projecting a shadow. If you look carefully to the image, you can see right on the top right side of this bright spot, which is a high altitude cloud, there is a dark feature, and this is the shadow of the cloud. Here it's the morning. We are very close to the southern pole, so actually this is kind of this is like on the Earth when you are in very high latitudes. You can have the days around the southern around the solstices, in which the sun doesn't set or the sun never rises. And here we are in a similar region. We are very close to the polar night. And close to this part, right now it's the morning, and there is where we see this cloud. Actually, with VMC, we have been working a lot on high altitude clouds in the twilights, right? Like in the morning, in the very early morning, and also in the afternoon, right after the sunset. And well, this is an amazing example of this kind of cloud, and I'm very happy that we are seeing so many interesting features in this image, mostly because they are features that they are kind of easy to appreciate. Apart from that, they were asking about the points, the other points, the other features in the image. Also, close to the night, a bit on the top of the feature, of the bright feature that I told that is a cloud, there is a white area, more or less. It looks a bit like if it was a milky area, and that's the polar cap. And in the border of the polar cap, there is something like there is a bit more darker, a bit more brighter in some parts. That's one of the craters. I will need to check which one is this, but this is one of the craters. The southern hemisphere of Mars is covered by a full of craters. And well, there are other things in the image. Basically, there are a lot of features because a lot of topographic features in specific, and there are also some hazes around. But like we have basically two very clear clouds, which are very opaque clouds, and they are very bright. And then we have a lot of topographic features and a lot of hazes that are around, but they are not so easy to spot.
One of the questions we've had a lot is about why we can't see any stars, and also if we could possibly see Mars's moons. So over to Colin.
Okay, so the question about stars is completely fair. The answer is simply that Mars is very, very bright. So you can see Mars from the Earth. You can see the planets appear. If you look in the evening sky tonight when the sun sets, the first thing you'll see as the sky gets darker, the first thing you'll see, other than perhaps trees and planes and things, is Venus. Venus is a very bright planet, but then to the left of Venus, you will also see Mars. It's bright, and it's bright here from Earth, but if you're very close to it, it is even brighter, and so it's so much brighter than the background stars that that's why they do not appear in this image. But if you were in space where this camera is, you would be able to see stars when you turn away from Mars, and that is in fact critical to how Mars Express navigates. And many of our spacecraft navigate by having star cameras, and they have on board, they have star maps, and so they, like mariners of old, they navigate using the stars, and that's how they know which way they're facing. So if you were where the spacecraft is, then you would see stars. There was another question about how we know these are clouds. So here's Jorge again to tell us.
No, but first I wanted to comment on the stars, because with EMC, actually, for calibrations, we have sometimes spotted both Phobos and both the stars, but for that we use very high exposures, and we point to a very different position where Mars is not present. Otherwise, Mars will be so bright that we will not be able to see anything.
So we often can see the moons of Mars from Mars Express. Mars Express, as you can see on the right hand of your image, it's got quite an elliptical orbit. So the big ellipse you see shows how far from Mars sometimes the Mars Express gets. And right now this ellipse shows it's got an apocenter. It's furthest from Mars when it's high over the southern hemisphere. But that does vary. So sometimes we're high over the equatorial latitudes, and when that happens, we pass really close to Phobos, which is the bigger moon of Mars. So sometimes we pass as close as 50 kilometers from Phobos, which is very, very close. And so then we get very good images indeed. And so Mars Express has been critical for building up images of that moon. So this is quite exciting because coming up in a few years, we've got a very ambitious mission, which is the Japanese-led Mars Moon Exploration mission. So ESA has a small part of that, and we will be collaborating with them. But that is not only going to image the moons in detail, it's going to orbit Phobos, and then it's going to land on Phobos briefly. It's going to touch down on the surface, grab a sample of the moon, and take off again. And then bring that sample, which is grabbed from the surface, it's going to bring that back to Earth. And that's very exciting. So apparently there's questions about the rotating graphic on the right. Jorge, do you want to say something about that?
Well, I don't know what are the questions.
Yes, I think some people would like to know about this graphic on the bottom right that we've been showing. And that was one that you made. Maybe you can explain a bit about it.
Yes, basically, as part of the LEAP observation, we wanted to allow people to really understand a bit what we are seeing. So when we made this graph, in a way that we can see that Mars Express is, as Colin was telling, in the apocenter of the orbit, or close to the apocenter. And in this graph, basically, we see the planet, and for this. For the map of the planet, we choose a topographic map of the planet, because this way we can really see what are the features, the topographic features that we have there. And well, indeed, the part of the planet that we can see in the image is the one. Basically, there is a circle that is around Mars, and then there are two lines that go from the border of Mars to Mars Express. Those lines are showing us which are the limits of the part of Mars that we can see. And then the circle that is around Mars, it is also allowing us to see which are the part of the planet that we can see. And what we see is the southern hemisphere. And well, basically we wanted to make this kind of graph to try to help in the understanding of what are we seeing here, which is basically the southern hemisphere. But for example, now in a moment, okay, now we have seen the Tarsis Vulcanus in our site. Let's wait a bit for another rotation. Like there it is, Tarsis Vulcanus. So we see that the limit of the part that we can see is in the volcano of the middle, and we can see the volcano of the south. The volcano of the south is Arsiamons, and we can see in the three-dimensional graph that this is part of the area that we can see, and indeed in the leaf image we can see this volcano like a brown spot, a dark spot in the left part of the image, and then as I told before, we have right now a small cloud right in the bottom of this volcano. This cloud is growing to the west, which is kind of the common thing in the season. In the season in Mars, we see a lot of orographic clouds in the volcanoes of Tarsis, and here we have a very good example. But well, basically,
okay. Stop talking about the clouds. We've got drama. We've got high drama here, because you may be noticing that the image is not changing. And so this image was acquired at 1805, and then if you add this travel light time, this image will have reached Earth at 21 minutes past the hour. But that is some time ago. So what has happened? We're just hearing from the people in the spacecraft wizards who are driving it. There is apparently bad weather around the receiving station, which is corrupting the reception of the signal. So this is where I would like to hear more about exactly what is going on. Which ground station are we using for the reception of this signal?
Cebreros.
So we're using the Cebreros station, which is near Madrid. It's just west of Madrid. My colleagues in Madrid, because we have Science Operations Center for Mars Express in Madrid, tell me that after months of dry weather, it's been raining in Cebreros. And so apparently bad weather at Cebreros is corrupting the signal. So we did have images coming through 10 minutes, 20 minutes ago. So we can hope that there are some more images will be released soon. So what's the latest on that?
I would just say, if people are interested, the ESA's S-Track ground station network has 3 very beautiful 35-meter antennas, and you can go onto the website. You can, if you're missing a live view because ours is currently frozen, you can actually get a live view of the deep space antennas, and you'll see in Spain some miserable clouds over our antenna. And breaking news that telemetry is actually back. So we might have to wait a bit to get the next image. But keep your questions coming in. Again, this is the first ever Mars Live. It's coming to you from Mars Express, ESA's 20-year-old mission orbiting the red planet. Colin.
So what we've just heard is we are now receiving signal again at the station. So you may be thinking, why are we not yet seeing an image? So this is now not the light time from Mars we're waiting for. We are now waiting for the reception, the latency between computer systems on Earth. But it is apparently working, and we're expecting the next signal to pop up on your screen anytime now. But it just does illustrate that we are using the spacecraft in a different way than we're normally used to.
Maybe Simon, maybe you could.
Do you want to say something about
we have Simon, who's been running around trying to figure out what's happening, and lots of people are asking about this in the chat. Simon, what's happened, and when can we expect the next live image?
Okay. So what we actually believe is going on at the moment is actually down to the weather. Unfortunately, alas, not the weather on Mars, but the weather in Spain is causing some intermittent problems with receiving the signal. This is not completely out of the ordinary. This does happen from time to time, and it's part of the daily life of operating spacecraft in and around the solar system. Right now, we have actually, as I say, we're starting to receive telemetry again. It is a little bit intermittent, so hopefully we will be able to get a few more images in, because there are effectively 2 different data streams coming from the spacecraft. There is effectively what we call the telemetry stream, so that's telling us what the spacecraft is doing, things like its temperatures, its battery voltages, what its reaction wheels are doing, where it's pointing, its various modes. And then there's a second stream, which is the science data. And so, as we say, it is a little bit intermittent at the moment. Hopefully we will be able to get some complete images in. We'll just sort of have to wait and see.
So in the meantime, we can try to answer some more questions online. So lots of great questions in there. One is from Ramona Virus. Why does the orbiter have an elliptical orbit and not a circular orbit? Is this on purpose? It is on purpose. There are many reasons for which you might want a low circular orbit, like if you have a radar orbiter or a camera, it's always useful to be close to the surface. But the thing is, it takes a lot more fuel to get into a low circular orbit. When you're arriving from deep space, you can imagine as you approach the planet, you accelerate as you get pulled in by its gravity, and you get closer and closer. And you have to make sure that you're not going to hit the planet, that you swing by it. So you accelerate as you get closer to the planet, and you swing by and you decelerate as you go off into space. So what happens at that point, if you want to go into orbit, is you have to use your rockets or some other way of decelerating and go slower and slower. And so what Mars Express did, for example, is it used its main rocket engine to slow down. And at that point, it then gets captured by the Martian gravity well, as you will, and then it enters this highly elliptical orbit as we have it here. And that is where Mars Express is, and that's why it's in an elliptical orbit. To go to a low circular orbit would have taken a lot more fuel. Simon Wood again, spacecraft operations wizard.
Yeah. Well, actually, I mean, the elliptical orbit's also there really for part of the science mission as well, because what the original kind of concept or the idea was that you would do your science when you're very close to the planet, and then you would have the period when you're further away to be able to communicate with the Earth. But actually, the orbit that Mars Express is in has been very, very carefully designed, because orbits aren't inherently, they're not static. They do move around, and so what you see is that Mars Express's orbit rotates throughout the Martian year, both what we would call sort of in plane, so basically sort of the point at which is closest to the planet constantly changes, and also it rotates sort of effectively with the planet as well. So you have a situation whereby the longitude and latitude of your closest approach is constantly changing, because both the planet's rotating underneath you as you're orbiting it 3 times a day, and also because the plane of the orbit is turning, you're constantly getting different latitudes as well, which allows you to get this global coverage over the whole planet.
And that's a point, we get this on Earth as well. Some satellites operate close to Earth, some satellites operate far from Earth. And when you have satellites far from Earth are great, for example, for weather maps, whereas satellites close to Earth are better for comms, communications, and spy satellites and things where you want high-resolution imagery. And so this orbit from Mars Express really does both. It gives you the faraway distant views, and as well as the close-up views. And when it's far from the planet, it can do things like fly close by Phobos, which is quite far from the planet. And it can also study the ionosphere and the solar-wind interaction. So sometimes it's far outside the bow shock, the ionosphere, and sometimes it's inside, so it can study that whole solar-wind interaction. Great. Have we got further questions, or do you want to say something else?
We have absolutely loads of questions. Some people have asked again, how often are we taking pictures? And it's roughly every 48 seconds that a new picture's taken, and it's roughly 16 minutes and 44 seconds for the light signal to get to Earth from Mars, and then a bit of time on Earth due to wiring and signals and things on Earth, but also the weather has been getting in the way a little bit of our live stream. But we're expecting a new image anytime now. But we've actually been joined by a new guest, Daniela, who's working at DLR. And maybe, Daniela, you could introduce yourself and say a bit about Mars Express and your special camera that you have.
Yes, hello everybody. This is Daniela. I'm working at the German Air Space Center in Berlin. I'm part of the HRSC camera team, so the stereo camera on board of Mars Express. I'm doing observation planning. I'm happy to do this. It makes a lot of fun. So I can decide which images we observe from Mars, for which purposes. And I'm struggling with ESA and all the other instruments to get those images down. And I know Mars very well. I'm working on this mission since 2005. It's almost the entire 20 years now. And I became part of this dear Mars family.
We had a question from Jacqueline Rosales, who's invited young students to watch. So hello to all of her students and any other students who are watching. And she said that she'd like a really kid-friendly understanding of how signals are plucked out of the air and translated into visual and readable data. And I think that's a good one, not just for kids, but I'd quite like it myself too. Jorge, maybe you could take this. How are signals taken from the air and translated into these images that we can see visually?
Yes, that's a long process because what we get from Mars is basically a bunch of ones and zeros. So there are a lot of interfaces in the middle because I, as a scientist who works in data processing, basically get some data from the engineers, but engineers have they have other systems and they see a lot of other things and they filter. Whoa, we have a corrupted image. This is because
art.
yeah, this is a bit like art. The thing is that because we have this bad weather, well, the program that we have here processing. Well, now we are receiving, I think. I think that it's going to solve in a few seconds probably. But basically, what we have here is that because we have bad weather, we lost some packets. I will speak about this in a moment. And because of that, the program was not able to solve the real image, and it basically put, here we have a good one. Yeah. I think that it's going better. Actually, Simon was telling me that the weather is going better. Basically, in the case of PMC, we have 76 packets. These packets are the kind of the way in which engineers put the information in a way that the scientists can really access to the data. And with these 76 packets, each packet includes more or less like 4 kilobytes of information, and from that, basically, each byte corresponds in the case of BMC to a pixel of the image, and then we create the BMC image from those packets. Now, because in the case of BMC, it was not designed to be a science camera. So there is a lot of processing to be able to obtain beautiful images like this. And this involves a lot of things. One of the things is the thing of the color. It's very common to ask, what is the real color of Mars? And in fact, in these images, they don't show the same colors as we would see with our eyes. Actually, color is a very complex topic related to the way in our eyes work. But basically, in the case of BMC, the color is more or less with the same system as with mobile phones. They have something called Bayer pattern, which is that each pixel has different colors, and then we make color images from that. But it's not like it's not the ideal science color image. And well, we also remove the noise, and we do different kind of processing to try to obtain an image that looks like this. From the ones and zeros that we get from Mars, and that engineers process a bit for us to help with that, because they really get actually away from the antenna that I will not understand, and they help us with that, of course.
But actually, I mean, for Daniela, it's even more complicated with your camera, because you don't just have a flat image. You actually take pictures in 3D.
Yeah, we do not take them in 3D. We take them in 9 different channels, 4 color channels and 5 panchromatic channels. And we use basically 4 of those 5 panchromatic channels, which are taken at different viewing angles to produce a digital elevation model. The principle is just as how we do this with our eyes. So we have 2 eyes of 2 different positions, and we look at the world with 2 different viewing angles, and our brain creates a 3-dimensional image of this. And we do pretty much the same, just a little more sophisticated. And so we get our 3-dimensional images. So, but this is a long way of image processing, and the raw images are, of course, they look like a photograph. But very long photograph. We don't take our images like a framing camera. So at one shot, you get the entire area. What we do is we have a scanner, a line scanner. We scan the surface in thousands of lines and stitch them together in a very long image stripe, which we also call an orbit.
Okay. The questions are coming in very fast, and I think we're taking a long time to answer these questions. So we can try giving some short answers to questions. There's some fascinating questions in there. One question I just saw is, what is the power broadcast from the spacecraft, and what is the power received at Earth? Simon, have you got? I think it's tens of watts at the spacecraft.
I think the transmitter on the spacecraft uses 120 watts of power.
and then it transmits about like 5 or 10 watts of transmitted power. So if you imagine a 10-watt light bulb or something like this, that is about how much power we are sending from Mars. So it's phenomenal to think that you can observe something consuming as much energy as a light bulb from 300 million kilometers away. So that's how much is broadcast, and then by the time it's 300 million kilometers away, we are sensitive. I think I saw a plot today of a millionth of a thousandth of a watt. It's a tiny amount, and that's just a testament to how sensitive the receivers are in these very big dishes. So that's the power question. Just jumping randomly between these questions, there was a question about the cost of the mission. So this is something we get quite a lot. Mars Express was built for, I think the project cost was 150 million euros. In fact, that's not correct because it's 150 million écus, the European currency unit, which is a precursor of a euro. Again, a reminder of how long ago it was that this was agreed and built. So if you just think the number 150 million sounds like a lot, but that is like 50 euro cents per person in Europe. So what can you buy for 50 euro cents? You may be thinking of a candy bar, and now you can think also of a Mars spacecraft. So if everyone contributes 50 euro cents, you can buy a Mars spacecraft.
I have a question that's kind of related to the value, but why does it matter that we understand about Mars? We had some questions asking about if we're talking about Mars weather or Earth weather that's getting in the way of the signals, but how does Mars help us on Earth? Does it help us, or is it just kind of escapism, interesting? What's the point?
So there are lots of different there are lots of different answers to this question, and different answers work for different people. Some people like to explore Mars because it's there. It's like the answer about Everest. It's the human spirit to wonder what is on the frontiers, what is out there, what is next door. Some people think of Mars as a future place to live or explore. I think in the short term, don't sell your house because it's not. It's very difficult. We can't breathe there. But the European Space Agency, like many space agencies, does intend to send people there on exploratory missions. If you are not moved at all by the exploratory instinct of Mars, you can also think that a lot of space exploration is useful for Earth. We have weather satellites observing Earth. We have communication satellites. We have GPS steering our vehicles. And the money spent on planetary exploration is at least an order of magnitude, at least 10 times less than what is spent on Earth orbiting satellites, which are used in our daily lives. And the planetary exploration does help develop technologies which are for our benefit on Earth. Daniela, did you want to add something?
Yeah, there's one neat thing about Mars I wanna add to the list of reasons why we do this all. The thing is that Mars and Earth are almost the same age, and they experience the same conditions in our solar system at the same time. But on Earth, everything, all the surfaces are relatively young because we have plate tectonics that eat the surface and renew the traces of the earlier terrestrial history. But on Mars, you have, so to say, a picture of our solar system that goes back to 4.2 billion years, so almost short after the formation of the planets. So if you study Mars, you can learn about the history of the Earth, about the history of the entire solar system, of all the terrestrial planets. You can analyze extremely old rocks, and you can learn a lot with what we call planetary analogy, vergleichen, the comparative planetary exploration. And this is a really neat thing.
I've said no audio, but maybe keep going. Sorry.
I'm almost done. I can add, as a geologist, the other advantages of Mars. It's relatively easy to reach compared to other planets. Try to fly to Mercury and you will understand what I mean. But the geologic processes that occurred on Mars are relatively similar to those that occur on Earth. So we have tectonism, we have volcanism, we have the action of wind, we have the action of water. We had the action of water on Mars, actually, but we can see when this water has been there, how much water has been there. We can deduce old climatic conditions 3.7 billion years ago and see whether Mars might have been habitable in this time. And the interesting thing is that we found out that Mars was indeed habitable at 3.6 billion years ago at certain places. And this is exactly the same time when life, the first microbial life, occurred on Earth. And isn't that a question? Isn't that interesting? And now we move on in answering this question, if this is related to each other or not.
Well, Daniela was responding as a geologist, and I would like to respond a bit as a climatologist. In the sense, I am really excited. I mean, I grew as a kid who dreamed of the space, and being right now here is like a dream, like a life dream for me. But as a climatologist, I think that studying Mars and studying the atmospheres of other planets are also a very good way to learn about our own planet. I think that in a way, it's like we can see ourselves in a mirror, and that way you can learn about ourselves. But when we talk to other people and when we learn about other people, we understand better or in a different way ourselves. And I think that with Mars and the other planets, it's kind of the same. When we study other planets, we can understand more about our planet. But also I have to say that we need to be realistic, and we need also to remember that we are now in a huge crisis, in a climate crisis, and we need to do much more than we are doing. In fact, when we look to the Earth from space, we usually think a lot on how beautiful is our planet. There is this pale blue dot image that was taken by the Voyager spacecraft, and I would like to say, save the pale blue dot. This is one of the things that we could say when we look back to the Earth from space. Because saving the pale blue dot, saving the core of the Earth, is not really saving the Earth. The Earth is really resistant. It's about saving ourselves, and this is what we need to think. We need to really act more for this, and this is what I can say as a climatologist.
I just wanted to say that we've got about 7 minutes left now, and Mars is gradually disappearing off. And a few people have asked kind of where it's going and why it's disappearing. So I think it's maybe worth touching on that just so to get back to what's being shown and then carry on again with this conversation, which is so interesting. But yes, Mars is gradually disappearing off screen. Why, and can we see it again?
It's disappearing off screen simply because Mars Express is moving past it. So it's currently heading effectively, as we said earlier on, behind it. You can see the elliptical orbit that we're in, and it's as a result of this, it's moving out of the field of view of the camera. We will see it again because it would, if we were to keep this live stream going for another 7 or 8 hours, it would come back round again. So we just had a question in terms of whether it's possible to recover the images that were not shown due to bad weather. In principle, yes. It is something that we do have to do from time to time because, as I said, we do have data outages due to weather or issues with the spacecraft or issues with the ground segment. And it's typically involved with, if it was just a problem with getting the data actually to the Mission Control Center here in Darmstadt, and it was actually received at the ground station, then actually it would be quite easy because we can actually connect. It's all recorded at the ground station, and we can simply re-request it. To actually get the data back from the spacecraft, we'll have to send a series of commands to it to tell it to copy the data that it's recorded to a different part of its onboard memory, and then we could redump that later. And are you going to? That would depend a little bit because we've actually to do this live stream, and because actually the data downlink on Mars Express is often extremely sought after by the instrument team. So they're producing science and they want their data down on Earth, and so we have to very carefully schedule all of the data dumps to make sure that we get everything down and nothing's left on board, because at the end of the day, if we can't get it back to Earth, there's no point recording it. And so actually for this live stream to work, we've actually had to turn off an hour's worth of data dumps, including some from HRSC. I'm sorry, Daniela. But rest assured, our mission planning team are actually working in the other room at the moment, because they were actually putting commands up that will go up next week that will actually then dump the data that would have come down in this pass were we not doing the stream.
So in case you missed the introduction earlier, we are talking to you live from the European Space Operations Center, and this is the control room. This is where they send control commands to the spacecraft and where they receive the data coming back to it. There have been some questions about the graphic on the right-hand side, people asking about whether there's an ocean on Mars. So the colors on that simply represent the elevation. So red areas are high, blue areas are low. You might immediately see that the northern hemisphere has lots of low terrains. If there was once a large ocean on Mars, then people think this would have been a sort of sea-covered ocean. There's also a massive impact crater in the south called the Hellas Basin. We think this may have formed when a late bombardment, a late object came and smashed and made a giant impact crater. So it's quite dramatic topography. If you look closely, you can also see some high points, which are very tall volcanoes, the tallest volcanoes in the solar system. Very tall volcanoes, the tallest volcanoes in the solar system. About why the image is disappearing. Again, it is the orbital period, and so that means that after 7 hours we will be back. By now, Mars Express has completed 24,000 orbits of Mars. So we do have confidence that it will come around again, because it's done so many times. And not only do our equations say this, but our experience says this as well. So just again, a reminder, why are we here today? Why are we doing this? So we are celebrating the 20th anniversary of the launch of Mars Express, which was at 7:45 p.m. Central European time, which is coming up in about an hour or so. But 20 years ago, and the mission was originally built and financed for a mission lifetime at Mars of 1 Mars year. It has now achieved 10 Mars years at Mars. It has now outlived its expected lifetime by a factor of 10, which is just a remarkable testament to everyone who built the mission, who designed the mission, and has operated it. And as one of the scientists who had an instrument which went up originally, this is just amazing to see, and it's wonderful. Over to you, Rosa.
Yeah, we just have 1 minute left and Mars is disappearing. But if you want to see more images like this, we actually have a less live, but still liver than most images of Mars. And that's if you go to the Mars webcam on social media. It used to be on Twitter. You can still follow at ESA Mars webcam on Twitter, but it's not updating anymore. So we have moved to Mastodon. If anyone is modern, they can go to ESA Mars webcam at mastodon.social, and the images that are currently coming down will actually go straight to Mastodon, not quite as quickly, because what we're doing now is difficult and special, and the team have spent ages preparing for this. So big thank you to them and to everyone that works on Mars Express and all the scientists. You can also go to Flickr. Slightly less modern than Mastodon, but still cool. You can get images on Flickr from Mars Express, and you can go to our website, as always, esa.int, and more news from Mission Control at ESA Operations on Twitter. We're all over the place. And our hour is up and Mars is disappearing. And thanks to everyone, to Daniela, Jorge, Colin, and Simon. And also you can have a look at the incredible HRSC mosaic image of Mars that also came out for the 20th birthday of Mars Express. And thanks to everyone who joined. We've been amazed at how many people have been watching, and it's been very special. It's really rare to get something like this so live. So thank you, everyone.
Yeah.
It was fun, thank you.
To sing happy birthday tomorrow. But you can all sing it yourselves at home.
Sing happy